Well, hello again. This week in math analysis, you've got two separate videos because we're going to be looking at two pretty much completely separate topics. And you notice on the opening slide, I put a clip of a headline that talks about the stimulus package that Congress passed this past week. And I'm going to use a graph that accompanied that article to introduce the topic we're going to talk about today. Here's the graph, and what it's showing is how much money different Americans can expect to receive from the stimulus package. Along the x-axis, it's showing income that people have, and there's actually two different graphs. One of them is showing how much a single filer taxpayer could expect to get back, and the other is showing how much a couple who's filing jointly could expect to get back. And by the way, this is also in addition to money they would receive for having children, which is an additional $500 in each case. Now, I'll show the graph again in just a minute, but the question I want to think about is the amount of money that a single person who makes varying amounts of money could expect to get back from the stimulus. So the questions I'm asking are what's f of 20,000? What's f of 75,000? What's f of 90,000? And what's f of 120,000? All of those are applying to how much money a single filer could get back. Here's the graph again. Since we are looking at a single filer, it's the bottom of the two graphs, the darker colored one that we're looking at. And again, I want to know what's f of 20,000, f of 75,000, f of 90,000, and f of 120,000. I'll let you look at that graph for just a minute, and then we'll talk about exactly what you do with this. So the thing about this graph is that it's a constant function, then it starts going down, and then it levels off at 0. And so when I answer my questions, remember if I ask about f of 20,000, what I'm looking for is what's the y value when x is 20,000. And you can see that that would be part of that original constant area that we'd have. It turns out that that amount is exactly $1,200. You can't necessarily tell it's exactly that amount from the graph, but you can tell it's more than 1,000 and definitely less than 1,500. And it does turn out that f of 20,000 is 1,200. For f of 75,000, I want to know what's the y value when x is 75,000. And it turns out that this is right at the end of that constant part at the beginning, so it's also $1,200. Of the four questions I asked, the one that's the hardest is f of 90,000, and that's because it's not on a constant part. What I have to do is first of all figure out about where $90,000 would be along the x-axis, and I've got to go up to that diagonal part of the graph and then try and figure out, okay, so about where is that for the amount? And the way I did it, it looks like it's around $500. We'll find out in a little bit. It's actually not quite that, but it is in the neighborhood of $500. And I marked the last one up a little bit differently. Here it's asking about f of 120,000. Well, 120,000 is down at the bottom of the graph, and basically we're saying that if somebody makes 120,000 bucks, they're not going to get anything back from the stimulus. So 0 is the answer. That graph is a perfect example of what we call a piecewise function. And a piecewise function is defined by different rules over different intervals. So like on the graph you just saw, it started off at a constant level, and then it went down, and then later on it was constant again at 0. So there's like three different pieces of the graph. That's why it's called a piecewise function. The problems you're going to do from that chapter 0 that I talked about last time will end up looking kind of like what I have here. What I'm showing you is what this function would look like if you wrote it out in symbols rather than as a graph. And basically, what this is saying is everybody that makes less than or equal to $75,000 is going to get 1,200 bucks. For people that make between $75,000 and $100,000, what you do is you take 1,200 minus 0.05 times x minus 75,000. Basically, for every dollar they make more than 75,000 bucks, they make 5 cents less on the amount of money they're going to get back. And finally, when you go over 100,000, it goes down to 0. And so the basic idea of this is there's 3 pieces that you'd look at. Now, one of the questions I asked before said, what's f of 90,000? And all you do for that is you just plug 90,000 into the middle part of that function. And I go to the middle part because x is between 75,000 and 100,000. That's how I know which part to use. And if I work it out, I take 1,200 minus 0.05 times 90,000 minus 75,000, and it turns out that the actual answer is 450. I guessed about 500 looking at the graph, and it is actually a little bit less than that. It is 450. That's the exact answer for someone who makes 90,000 bucks. Here's another piecewise function. This one doesn't stand for anything in particular. It's just a bunch of numbers. And I'm asking you to look at this function and figure out what's g of 1, g of 3, g of 4.5, g of 5, and g of 7. So 5 different questions. And the key to all of them is to think, which part of this do I have to plug into? Which piece am I looking at each time? So I'll give you a minute to see if you can figure out those 5 answers. The important thing here is that I use the top formula, 2x plus 3, when x is less than 5. And that's why the first 3 problems I'm plugging into the top formula. I take 2 times whatever x is, and then I add 3. And you can see g of 1 is 5, g of 3 is 9, g of 4.5 ends up being 12. Once I get to 5, I use the bottom formula. And I use that for 5 itself because it says x is greater than or equal to 5. And I also use it for everything that's bigger. So plug into that, and it does turn out that g of 5 is 26, g of 7 is 50. Here's the same function, and I'm just asking you to find 3 other answers, g of negative 4, g of negative 9, and g of 0. Every one of these is less than 5. There are sometimes questions people find tricky because they'll look at something like negative 9 and they think 9 is bigger than 5, but anything negative is going to be less than 5. So all 3 of these I plug into the top formula. I double whatever x is, and then I add 3. You do need to be careful that, like, when you take negative 18 plus 3, you do get negative 15, not negative 21. So yeah, our answers are negative 5, negative 15, and 3. Here's another piecewise function. This time there's 3 different parts to it, and I have 8 different questions that I want you to find. H of negative 5, h of negative 0.5, h of negative 0.1, h of 0, h of 0.1, h of 0.2, h of 2, and h of 100. So again, look through those, see if you can figure out what all of those are going to be. And again, the important thing is going to be which formula do you plug into to get each answer. So the first three are all negative numbers, and negative numbers are always less than 0. That's why we want to plug into the top formula, 3x. You take 3 times negative 5, 3 times negative 0.5, 3 times negative 0.1, and while I didn't really have to use a calculator, you can see that the answers are negative 15, negative 1.5, and negative 0.3. All of those, it's the top formula I plug into because they're all less than 0. The only one on here where h is 0 is the one that says h of 0. And so that one problem I plug into the middle formula. And I take 0 to the fourth, which my common sense tells me is 0, plus 1, and I end up getting 1. So 1 is what h of 0 is. And the other problems are all positive numbers, which is why you want to plug into the bottom formula and basically just add 2 to everything. Sometimes people get sort of paranoid when they have a number like 0.1 and they think that's really, really close to 0, so they think they should use the one that's 0. But that only works for 0 itself, not for anything close. So since it's positive, you do have to plug into that bottom formula. And again, you just add 2, so 2.1, 2.2, 2 plus 2 is 4, and the last one, 100 plus 2, would be 102. You're going to see some questions on the worksheet that you have for this where it's going to be asking you to evaluate piecewise functions, exactly what we did on these last few problems. And again, the important part is you got to figure out which of the formulas do you plug into, and then just crank out the answer and see what you get.